a lot like the last one. The only difference in this case is that both the objects are moving in the vertical plane. You've got two masses, 25 kilograms and 10 kilograms. You can see, I hope you can see that when you let go of this system, when you let go of the two masses, the 25 kilogram is the heavier one. It's going to cause an acceleration down, and the 10 kilogram is going to cause and therefore the 10 kilogram is going to get accelerated up. So let's draw free body diagrams for these so that we can make it really clear what's going on. Here's the 25 kilogram and here's the 10 kilogram. So the force is acting on the 25 kilogram. Well, there's a force of gravity acting down, and there's the tension force, let's just call it T, acting up. Same thing, right? Force of gravity down on the 10, tension up. Now just be careful, because remember we said this guy's going to accelerate up, and let's take the direction it's accelerating to be positive. 25 is going to accelerate down, so we're going to make down direction positive, and that makes a difference for our problem solving. So when we go to do this problem, we are going to look at each individual mass. I'm going to do it the two systems of equations way. So let's start by looking at the 25 kilogram mass. So MA equals the sum of the forces. Okay, so then 25A equals, well, the sum of the forces, taking into account the FG is positive, it's going to be FG minus T. You can call it FT or T. So we have 25A equals 25 times 9.8 minus T. And then just multiplying that out, 25A equals 245 minus T. And we have two unknowns, so that's kind of the dead end for that. Then looking at the 10, we do the same thing. MA equals the sum of the forces. So now since we're looking at the 10, it's 10A. The sum of the forces in this example is, now be careful with the sign convention here. See that up, this object's going to accelerate up. So tension is actually positive and FG is actually negative. So we get 10A equals T minus 10 times 9.8. So then 10A equals T minus 98. Okay, again, that's as far as we can go with that because I have two equations and they're both unknown. So where do we go from there? Well, we set up our system. So that's equation 1, that's equation 2. You can solve these any way you want. I'm going to set it up so I'm going to solve each one for T. So in this equation, to solve for T, I get T equals, it would be 245 minus 25A. And then solving equation 2 for T, I would get 10A, T equals 10A plus 98. And then setting these two equal to each other, I would get 245 minus 25A equals 10A plus 98. So then I would get 35A equals, let's see, I'm doing this wrong again. 25, solving this equation, we get, taking the 25 over, I get 35A, and on this side it becomes 245 minus 98. So A equals 245 minus 98 divided by 35, that equals 4.2 meters per second squared. And that's the acceleration, and from the acceleration we can just plug it into either one of those equations, maybe stick with that one, and solve for T. So T equals 245 minus 25A, so that equals 245 minus 25 times 4.2, and we end up with 245 minus 25 times, and that equals 140. So the tension in the rope is 140 newtons. The acceleration of the system is 4.2 meters per second. You could have done this the other way. You could have done this by considering it 35 kilogram mass, 35 kilogram mass. Just think about what the two external forces would be pulling it. Pulling it in one direction would be the force of gravity on the 10 kilogram mass. Pulling it in the other direction would be the force of gravity on the 25 kilogram mass. It's kind of a weird idea, but you can just use those two mg's to find the acceleration of the object, which would be in this direction. I won't go through that math, but that's another way you could have solved it.